all under the announcements. It's in there somewhere. Right, I have should be the fifth thing down. It says end of semester survey.
Oh, got it.
You found it?
Yes.
Okay. Cool. All right. I think we left off on number 27. So again, we're still on the no calculator multiple choicers. If you have that packet with you, I invite you to take it out so you can follow along. So on 27, it says the graph of f prime, shown in the figure above. Which of the statements must be true? F is continuous on the open interval from A to B. F is decreasing on the open interval from A to B. The graph of f is concave down on the open interval from A to B. So again, what I would do is I would address each one of these statements individually, decide if they're true or false, and then go to my multiple choice. I guess if I get a falsy, I might be able to eliminate some choices from my multiple choice, and I'd probably do that as a false came up. So statement 1 says f is continuous on the open interval from A to B. True or false? True. Why is it true? Excellent. Yes. Since the graph of the derivative is defined for all values, we know f is differentiable, and that implies continuity. The reverse is not true, right? Continuity doesn't guarantee differentiability, but differentiability does guarantee continuity. Okay? So seeing that, I can eliminate choice D because, well, I know I is true, so that has to be in my answer. The next one says f is decreasing on the open interval from A to B. What does decreasing mean? Okay, in terms of derivatives, though? Means the first derivative is negative. So I have a graph of the first derivative. Is it negative the whole time? No way, right? Look at all this stuff. That's all positive. So this is false. So that allows me to dump B. I'm looking pretty good. It's a 50-50 guess. If I'm down to 50-50s on each one of these, I feel pretty happy if I can get to 50-50 land. But let's keep going. Here it says the graph of f is concave down on the open interval from A to B. What does concave down mean? Second derivative is negative. Now, that is equivalent to saying the first derivative is, decreasing. So if I look at that first derivative, that's what we have a picture of. Is that decreasing from A to B? If I walk, am I going downhill the whole time? Ya betcha! So it should be 1 and 3. So this observation here is an important piece. That's like a nice little fact that can make a lot of problems, especially if you're given a graph. Easier conceptually if you remember that, okay, second derivative being negative is the same as the first derivative decreasing. So I don't actually need to calculate a second derivative. I can just look where the first derivative is decreasing. All right. 28 was one of our most guessed problems because it was a related rates problem. Oh no! It says an isosceles right triangle with legs of length S has an area A equals 1/2 S squared. At the instant when S is equal to square root 32 centimeters, the area of the right triangle is increasing at a rate of 12 square centimeters per second. At what rate is the length of the hypotenuse of the triangle increasing in centimeters per second at that same instant? So we're given this. What's up? I do not. Would you like to use the bathroom? Of course. So we're given that information, right? Everybody agree? First thing I would want to do, since I'm given a dA dt, is I want an equation with a dA dt in it. So I'll just take the derivative of both sides. Is everybody okay with what I did there? Okay. I have a number for dt, and I have a value for s. Well, I can solve for ds dt, but that's not exactly what we're looking for, is it? Right? The question's asking for the it's asking for like dr dt, right? Do I have another equation that relates s and r? What would it be? Yes, the Pythagorean theorem. So s squared plus s squared is equal to r squared. So if I take the derivative of both sides, I end up with 2s ds dt equals 2r dr dt. I have s. I know that's 32. I have ds dt. I know that's 12 over root 32. I'm looking for dr dt. What am I missing still, though? R. How do I find... Yeah, Tessa? Oh, thank you. How would I find R? I'll use the Pythagorean theorem. What's S? Root 32, right? So R is 8. So we have 4 times root 32 times 12 over root 32 divided by 2 times 8. Goes all the way down to 3. I plugged in root 32 for S and then solve for R. Because that'll give me the length of R at that instant, right? Because the length of S is root 32 and they're hooked together. Does that make sense? '28 was one of the least correct, or I'm sorry, 29 was one of the least correctly answered questions. And I felt bad because this is like an Algebra 2 question. Okay. One horizontal asymptote, no vertical asymptotes. Going back to algebra 2, when do we get a vertical asymptote? Denominator equal to 0. So if there's no vertical asymptotes, what can I say about the denominator? Can't equal 0, right? Which one of these denominators can never equal 0? A and D. So we can immediately discard B and C, right? If x is -1, B gets a 0 denominator. If x is 0, C would have a 0 denominator. Immediately I can discard those two. Now I just need one with one horizontal asymptote. When does a rational function have a horizontal asymptote? That's what A is, right? This should be something we can remember from algebra 2. As long as the degree of the numerator is less than or equal to the degree of the denominator, you'll get one horizontal asymptote. If the degree of the numerator is greater, you get the slant asymptote. This you might recognize as a logistic function where it has like two horizontal asymptotes. It's like an S-curve. We talked about that last year in pre-calc, but very briefly. So you're excused if you don't remember that one. You spend a lot of time in Algebra 2 talking about rational functions and how to find the asymptotes there. A little less excusable to forget that one. But that's what I'm using, zero calculus. Now, could you do it with limits and stuff? Yeah, but like, I don't want to do that. Like, I already know how to do this problem, right? I'm just going to do it the much easier way where I just have a rule that I apply that I just have to remember. You guys happy there? Is this helpful when I go back and talk about like what's the easiest way to try to do that? Like where's the knowledge gap what should I see here? I'm trying very hard to like break these into component parts. All right. Last one. This should be like a 10-second problem. You just had to recognize what you're seeing. So, what's the limit definition for a derivative? It's the limit as n approaches infinity of the sum from I equals 1 to n of like f of xi star times delta x or something, right? This is a Riemann sum approximation. The question tells me that is, or can be found using that formula. This is a rational function, right, that we're doing the limit of. To do that, all I need to do is look at the degrees, because it's like the same kind of rules as the asymptotes from a rational function. What's the degree in the numerator? 2, because you have an n plus 1 times a 3n plus 1. You'll get an n squared out of that. What's the degree in the denominator? 2. If the degrees are equal, I just want the leading coefficient over leading coefficient. What will the leading coefficient in the numerator be? Not 2. 6. Right? You'll have 2 times 3. So this limit is 6 over, and the leading coefficient in the denominator, 1. 6. Again, if we recognized what they're trying to get us to use, it's a 10-second problem, right? The limit that I had to do was a very easy limit because it wasn't one I had to do any limit rules. I didn't have to do L'Hopital. I didn't have to do direct substitution. You could have done L'Hopital if you forgot how to do that. But I feel like when we talked about limits, that was way back in the first semester, we talked about some of these shortcuts, right? Or if you have a polynomial over polynomial, you look at the leading term and use the same rules that we did for rational functions for horizontal asymptotes, basically. Does that feel okay? Are there questions from this first piece on problems that you desperately want to talk about that I did not yet talk about? Again, I skipped around a little bit and tried to pick the stuff that was either the most guessed or the least correct. But some of us did good in some places and not in others. Take a minute, flip through. There's something you're like, yo, I saw this and I just was befuddled. Can we talk about, or I think I got this right, but like it took me like 6 minutes to do it. Was there an easier way to do this? I'm happy to answer any kind of questions like that. Isabel? So on top of the file cabinet are the 4 parts of the, or the 4 tests that we gave out. You're welcome to any or all of those if you need an extra, or you weren't here when I passed it out. Jacob. 26. Yeah, so the idea here on 26 is I wanted to try to do this without having to do L'Hopital. You could L'Hopital it. It's not terrible. But to do this in like as a 10-second problem, I look at the inside of the natural log and I go, okay, I have an exponential and a linear piece. In comparison, the exponential is growing so much faster that the linear piece doesn't really matter, right? It's like if I am playing tug of war and I've attached a pickup truck to my end of the rope, if I also push on the pickup truck, am I really making much of a difference? Not really. The same idea with the plus x. It doesn't really make a difference. The exponential is like a pickup truck attached to your rope. So if I do that, then the natural log of e to the 3x is just 3x over x. And then we just reduce down, I get 3. That's like the 10-second way of doing it. You could L'Hopital it. It's not terrible. It's not super long, but it's a chain rule or 2 chains in there. So it's like, it's like not trivial to do. And it kind of stinks, but you'd end up at the right place, I think, without a whole lot of extra effort.
Thank you.
Yeah. You might have had to do a couple of differentiations to L'Hopital. You might have to do L'Hopital more than once, too. Which, again, I look at that and I'm like, that's the way I want to think about it. At least on a multiple choice question where nobody's looking at your work, right? All right, I'm going to move on to part B then. We can always come back and later next week and talk, or at the end even, to do some more stuff from A, if you're not sure. But I'm going to move on to B. So 76 was the second most correctly answered question on the part B multiple choice, which is great. So I'm going to skip that and go to 77. This question is a fundamental theorem of calculus part 2. If capital H is the antiderivative of that function, then I know the integral from 2 to 5 of that function is equal to h of 5 minus h of 2. That was the key step. Because this piece you can just get a number on your calculator. This piece we're told is pi. So we're just like doing some algebra 1 algebra here after you've done that. But that was the key observation, is knowing that h is the antiderivative of that. So if I integrate that from 2 to 5, I'll get h of 5 and h minus h of 2. And then from there, you can just do some subtractions. Oh, I didn't read through the answers to this. I should have done that, right? Let's take a time out here and let me read through the answers for part B, so you have those. Okay, are we ready? 76 is D as in dog. 77 is boy. 78 is cat. 79 is boy. 80 is ace. 81 is dog. 82 is dog. 83 is cat. 84 is dog. 85 is boy. 86 is cat. 87 is boy. 88 is cat. 89 is ace. And 90 is cat. Is everybody okay with how I would have typed that into my calculator to get the answer to come out? I think we've practiced that a couple of times or several times. We should be okay doing that. If you're not, please let me know, and we got to make sure we can do those kinds of things in our calculator, because you absolutely have to be able to do that for the AP exam. 78. Your calculator will not help you here. It says the continuous function f is positive and has the domain x is greater than 0. If the asymptotes of the graph are x equals 0 and y equals 2, which of the following statements must be true? So I would sketch a little picture in. So here's x equals 0. Here's y equals 2. So I know that my graph is going to look like, something like one of these, right? Actually, hold on. It's x is greater than 0, so it's only one side of it. Everybody agree? One of those two things is going to be what the graph looks like. So if I look, as I approach 0 from the right, I either need to be going to positive infinity or negative infinity, correct? So I can cancel out b, because there 0 is going to, or x, as x approaches to 0, y is going to 2. That's not right. And I can discard d, because Well, it's just not even like there's no limit as x approaches 0 from the right. Like we know that has to be one of my limits. So I'm down to 50-50. The other end is as x approaches positive infinity. So the other piece here, that's not the right one. So already I've process of elimination this out to it's got to be C. Yes. Sure. Right? So this arrow is like x approaches 0 from the right. And like this arrow is x approaches positive infinity. And right there, that's like almost enough for me to, you know, and here the y is going to either positive or negative infinity. Here the y is going to 2. Does that make sense to you guys as to what I was looking at? Again, I tried to draw a picture, or at least envision the picture in my head, but that's the idea. 79. I'm skipping because the majority of us got that one. Or I'm sorry, 70. Yeah. Oh, hold on. That was 78 we just did. Okay, so 79 we're skipping. Seemed like most of us got that one. Here, surprisingly, I thought this would have been a pretty easy problem, but a lot of people missed this. I think probably the issue was that they gave you the first derivative. So all I need is the second derivative. And what am I looking for here in concave up? First derivative greater than 0. Easiest way to do this on the calculator, check this stuff. I think you're going to super dig it. So I'm going to type in this first derivative that was given to me. Bye. Happy bloodletting. So I'm going to type that into y1. I don't want to graph that, though, so I'm going to turn off the equal sign. Into y2, check out what I'm going to do. I'm going to do math, command 8. That's the derivative command. So I'm going to differentiate with respect to x. I'm going to differentiate y1. And where it says x equals, I'm going to put that as x. And then I'm going to graph this on my standard window. So where is this above the x-axis? 2 to positive infinity only. Whoa! Like how much of a time saver is that, not having to do like any algebra at all? Right? Like I don't have to differentiate. I don't have to set it equal to 0. I don't have to try to solve it. I don't even have to know how to do the derivative. Isabel. So that command is math 8. And then I just filled in. Yep. Well, the x I have to fill in and the x I have to fill in. But that's just math command 8 is the derivative. Like how nice is that? Like my calculator can get me the graph of the derivative and I don't actually have to know how to do the derivative. That's nice, right? Like saves me some headache of like, even though this one, the derivative was very easy to do, it's still like an opportunity to drop a negative sign. Or to say 2 times 3 is 5. Or something like, oh my God, I can't believe I did that. Because those are the mistakes that I make. And I'm like, oh my God, I can't believe I did that. All right. 81 was turned out to be one of the hardest 2 problems for you guys, or the least correct of the 2 problems. Again, your calculator is useless to you on this. So we're given a graph of f, and we're asked which one of these could be the antiderivative of f. So usually the notation we used was like cap f. If lowercase f is the function, its antiderivative we use as cap f. But that's the same thing. It's just thinking about this guy is f prime, and that guy is f, right? You guys see what I'm saying? Now, why do I want to think about it as the derivative? Well, what happens when the derivative is equal to 0? Those are local mins and maxes. And that's the only, other than when the function is undefined, and here the derivative is never undefined, those are the only places so that I can get a local min or max, right? So I'm going to go look at my answers here and look at which ones have local mins and maxes at some number between -2 and -1, and then +1 and 2 only. I have 2 choices now. That's super great, right? If I can get to 50-50 and I have to guess from there, I don't feel too bad about it. Everybody's okay? Now what I'm going to do is I'm going to look to see whether they should be mins or maxes. So here I'm going from negative to positive. That is a local min. Here, this is a local max. Boom, done. Got to be D.
Like the 0 on A, wouldn't that automatically tell you that that one doesn't work too?
Oh, yes. Perfect, yeah. Absolutely. Yeah. Excellent. So A had the extreme in the right x values, but it had an extra extrema that we should not have. You could cross it out right from there. Yeah, so D is the only option. Does that feel okay on how to do that? Again, I'm trying to what do I need to notice? How am I thinking about this? Really trying to be as meta as I can going through these. So you can see kind of the strategy on how to do something ideally quickly, and what are the ways that I need to think about these things. 82. Yeah, so 82. Yes, of course. Says a particle travels along a straight line with velocity v of t equals yada, yada, yada. What is the total distance in meters traveled by the particle on this interval? How do I find the total distance given a velocity? Integral, okay, of velocity, close, absolute value. Because it's a total distance. If I want just the displacement, right, what its new position is, then I don't need the absolute value. And at that point, I'm just typing my calculator and pressing enter. I'm not doing it by hand. On the calculator section, I am doing nothing by hand. I'm using my calculator to do the whole shebang. I'm doing all of it on my calculator. Yes, Isabel. Yes, so if you press math and you go over to the number column, I think the first option is ABS, and that'll put the absolute value bars in there for you. You're welcome. Any questions on what I did there? 83, 84, 85 were all pretty good, so I'm going to skip past those ones. 86, we had a lot of guessing on. and not a lot of correct responses, which made me sad because this is one we have done. This was in definitely a multiple choice question that I picked in a block of multiple choice questions that I had you guys do. I was like, oh, I remember this one. So it says the twice differentiable functions f, g, and h have second derivatives given above. Which of the functions f, g, and h have a graph with exactly 2 points of inflection? What's an inflection point? How am I going to find that on a second derivative? And we have a change in sign. So it has to go from negative to positive or from positive to negative. A bounce does not count. So what am I going to do? I'm just going to graph these things on my calculator and look. So you could do this, you could graph the first one without doing anything on your calculator, because I know I have a x-intercept at 0, an x-intercept at 1, and an x-intercept at -2, right? So this function is a degree 6, so it's an even function with a positive leading coefficient. So it's going to, I know the ends are going to look like that. The degree on, or the multiplicity for -2 is degree 3, or is 3. So it's going to like kind of come through as a bend. The multiplicity on 0 is 1, so it's just going to go straight through. And then the multiplicity on 1 is 2, so it's going to like bounce. So I have 2 inflection points here, right? If I shift this up 1 unit, this would still, I'd still have an inflection point. It's just going to move like over to here a little bit. I'll still have an inflection point here, but it like moves over here just a little bit. And that doesn't intersect anymore at all. So I still have 2 inflection points, right? So I know I have F and G. Does H work? If I move this down, still have an inflection point there, but it's now like over there. Still have an inflection point here, but it's moved to like over there. And here I've picked up 2 more inflection points, right? Because like this part of the graph and this part of the graph would cross. So that would have 4 inflection points. That's not what I want. So it's going to be this one. Although I would not have done it that way by hand. I'm just stating that like this could have been in the no calculator section. It would not have been absurd to do that. That's how I would have done it. It's just generate the graph for the first one using what I know about multiplicities of zeros and graphs of polynomials, and then just imagine what would happen if I moved it up or down. Is everybody okay? All right, 87. So to do this, what I would do is I would look at the change. Oh, it says, all right, sorry, I should read the question. The table above gives the values of a function at f at selected values of x. If f is twice differentiable on the interval from 1 to 5, which of the following statements could be true? Could is the operative word here. We're not guaranteed anything. But what I'm going to do is I'm going to kind of look at what's going on if I look at the slope. So here the slope's -5, and then -4, and then -3, and then -2. So I know that the first derivative could be negative, correct? It can't be positive, though, because it's the slope from 1 to 2 is negative. So at some point, even if there was like a positive part in there, it would have to go negative again. It can't be positive the whole time, right? Now I need to decide if we are going to be increasing or decreasing there. So if I look at the slope of these, that's plus 1, that's plus 1, that's plus 1. So what are you noticing here? It's increasing. So f is negative and increasing. That's kind of what I looked for, or how I did that. Does that make sense to you guys? So those slopes keep getting bigger, which means that that first derivative would be increasing. Seemed like there were a lot of people felt like they had to guess on that, weren't really sure what to do with it. 88. Lots of people got this right. This was one of the second most correctly answered, but it had the most guesses. So let's talk about it. It says, let f be the function defined by yada, 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 and g the function defined by yada, yada, yada. The line tangent to the graph of f at 2 is parallel to the line tangent to the graph g at a, where a is a positive constant. What is a? So to do this, the numbers are such that I'm probably going to try to do this by hand, because I don't think I'd be able to eyeball the difference between 0.04 or 0.43 and 0.447. So I'm probably not going to try to just graph this and look, although maybe you'd be able to tell. If you're lucky, it would maybe be at a 0 or something, like I'd have a slope 0 and you could use your calculator to just do a min-max thing on it. But I'm not optimistic that that would be the case. So I'm going to calculate f prime. And I want to set that equal to, and I want to find f prime of 2. And then I want to take g prime and set that equal to f prime of 2. Everybody's okay with that? This part now I'm going to do on my calculator. Because again, like I told you, I'm not really going to do anything by hand. So my f is the natural log of x squared plus 1. Oops, too many. And there's that. And I want that at just at x equals 2. So I'm going to change that to 2. And then g is x to the 5th plus x cubed. And again, I could do the derivative by hand here, but I'm not going to risk it. I'm just going to do it on my calculator. Oops, and I don't want to graph the g. So now I'm just going to look at look for the intersection between these guys. And looking at my values here, I really only need to go from 0 to 1 on my x. So I'm just going to hit that. Here's f prime of 2 being drawn in. Here comes g prime of x. Looks like it's happening somewhere over here. The cross, second, trace, intersect, enter, enter, enter. 0.447. How much easier is it with your calculator if you know what to do? Like if I know how to use my calculator well and how to generate like the graph of a derivative and like use my calculator to do like graphs, intersections, to do solvings, like boy, that helps, right? Boy, that's helpful. On a situation like this where you have like, what is it, like it's 3 minutes a question? If I can get it in my calculator and boom, like done, save myself a bunch of time to where I can if I have to figure something out and muddle around a little bit, buys me some time to do that. The last one we'll do is 89. This was the other least correctly answered question. One person answered correctly 89, and one person correctly answered 81 between the two classes. So let's make sure we talk about this. It says, let f be a continuous function for all real numbers. Let g be the function defined by g of x equals the integral from 1 to x of f of t dt. The average rate of change of g on the interval from 2 to 5 is 6. Which of the following statements must be true? When we see average rate of change, what are we looking at? Slope. So I know that g of 5 minus g of 2 over 5 minus 2 is equal to 6. Is everybody okay with that? Now, 5 minus 2 is 3. What is g of 5 minus g of 2? No. Think the fundamental theorem of calculus, part 2. That's
Why is it?
because g, okay, let's go back then. So g of 5 then would be the integral from 1 to 5 of f of t dt minus the integral from 1 to 2 f of t dt, right? Oops. Everybody good there? So the integral from 1 to 5 is the same as the integral from 2 to 5 plus the integral from 1 to 2, right? Is that okay? And what is this? It's the average value of f from 2 to 5. I thought this was the hardest question on this set of multiple choices. Really requires you to really fundamentally understand what you're looking at. But if you saw what to do, like, okay, average rate of change means I'm going to write a slope. Okay, well, g, that is g of 5. Okay, I'm just going to plug 5 in for x for the function given for me, g. So I have these two integrals that are being subtracted. I'm going to chunk those two integrals together so I can cancel the subtraction. And what I'm left with is, the hard part to recognize is that that's the average value of f from on the interval 2 to 5. Maybe if I'd left the 3 as 5 minus 2, it's maybe more obvious. That was a tough one. I thought that was the hardest thing in this set of multiple choices. Other questions from this set that I didn't address. Again, I tried to pick the things that were either most guessed or least often correct. Isabel.
For number 84, I was stuck between C and D, but I chose C because I thought because the bounds are from 0 to 3, that already includes the 1,000. But because when T is 0, it's 1,000, so why would they?
So what this is saying is, so like, let me do it this way. So R of t is a rate, right? So it's like the velocity. So like, let's think about this as a velocity problem, right? Let's say that at time 0, we've already gone 100 miles. And for the next 2 hours, I'm driving at 50 miles an hour. So here's time 0. And this is like 50 up here. So the amount of distance I've accumulated is the integral of that velocity, so it's 100, right? But I've already gone 100 miles. So that 100 didn't count. So it is, I need the 100 plus. You see how, like, if I reframe it as like a question that's like really easy conceptually, that's like, oh, of course, yeah. But this is like the C in our plus C. So this is saying like P of 0 equals 100 or 1,000, and our P of X or whatever would be C plus the integral from 0 to X of R of t dt. Because when I do that integral, I get the plus C. So I'm always going to have a plus C. And that's often what when they give you an initial amount, that's kind of what they're doing. Does that help, like, conceptually? Okay. Yeah, and that's a real common way of phrasing one of these accumulation problems, is them to give you the initial amount as your plus C, and then you'll do the rest of the accumulation with an integral. And this one, 84, Isabel, there's no reason that couldn't have been a no calculator question, right? You need your calculator to do nothing here. So, anybody else? Okay. I'm going to go to the, do you got one, Isabel, or no?
Yeah, sorry.
Go ahead.
83.
83? Okay. So, do you want the way I would do this with my calculator on the test?
Yeah.
Okay. So, what I would do is I'm going to type in this function into y1. And then I don't want to actually look at the graph of that, because maybe I don't remember even my like first or second derivative test stuff to where I could do something with this. What I'm going to do here is I'm going to, in my calculator into y2, I'm going to do math. I'm going to do command 9. And I'm going to do the integral from 0 to x of y1 dx. And then I'm going to look on the window from -1 to 9. And I might have to adjust my y mins and y maxes, but I'm going to just look for the maximum value now. So I'm going to use my calculator to do that max command. And I'm not seeing a picture coming in, so I'm probably going to have to adjust my windows here. Oh, it's thinking for a long time here. It's okay. I hope I didn't break it. I think I did that right. All right, stop. I don't like what it's doing now. All right, so let's do this instead. That was taking entirely too long. I'm just going to graph this thing then. Now, what am I looking for? If I'm looking for relative maximums, I'm looking at the zeros, correct? Yep. So I need where the first derivative is equal to 0 and where I move from f prime greater than 0 to f prime less than 0, right? So it's increasing to decreasing. So I'm just going to look at my picture here. So that would be this spot right there. So I'm just going to find that 0 on my calculator, and that's my answer. How'd I do what? You said it so quietly, I just didn't hear it. Yeah. If I did it with the integral, I'd be looking for wherever the highest point on the graph is. So I'm just going to use like the min-max command on whatever that highest point is. Again, if you don't remember your derivative test, you can still do that, right? It's like, oh, crud, which one is the max and which one is the min? You know, like, yeah, it might take a long, I was frustrated already by how long that was taking, so I was like, I'm done waiting on this. Let's do it a different way. That I have to remember a little bit of what's a min and a max, or how to find those using the first derivative, but okie doke. All right, FRQs. I'm going to start on the calculator ones because there's only 2 of them. Blah, 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 lots of talking. Okay. Look at that. Okay. This, part A, for number 1 on the calculator free responses, this is a 1-point question. So all it's worth is 1 stinking point. Because all they want you to do is to type this crap into your calculator. I saw some of us trying to do this by hand. Please, for the love of God, in the calculator sections, don't try to do anything by hand. To do this on my calculator, all I'm doing is typing this into Y1. Oops. And I have to remember one thing. What do I have to remember? What's the relationship between velocity and acceleration? Acceleration is the first derivative of velocity. So math, command 8, differentiate with respect to x. I put that answer into y1. And we want when t is 5.1. So 6.49 meters per second, done. That's all I want to do. In fact, they don't even care about the unit, so if it doesn't specifically ask for a unit, you do not need to give one. What work would I show on my paper? I would write just this. That's all I would write. You'd get full points for your 1 full point for that. That's all you would need. Tells the reader exactly what you did, what your answer is. It doesn't ask for anything else in the question. Don't do more than you need to. Jacob.
How does cardanoids work? If you put the right answer, would you get it anyway, or would you have to show?
So if they're I think if you just wrote 649 on this one, you'd probably get the point. If there's multiple points, there's usually when you get if you're a grader, they give you okay, this getting to this point is 1 point, getting this thing is 1 point, doing this is 1 point. They tell you kind of what you're looking for, and I'll do that as we go through these. So the next one says find all the values t on the interval from 1 to 2 for which the speed of the particle is 1. What's the difference between speed and velocity? Velocity has a direction implied, i.e. if you're going 1 meter per second forward, your speed is 1. If you're going 1 meter per second backwards, your velocity is -1, but your speed is still +1. So what do I want to find here? I want to find that, where the absolute value of the velocity is 1. What I've written down there is worth 1 point. So to do this now on my calculator, I'm going to unmark that y1 because I don't want to graph that. I want math, number, absolute value of y1, and then 1. And I only need to be going from 0 to 2. And I don't probably need this much, but I'll go 0 to, or -3 to 3 or something. I'm just kind of guessing. So here's my velocity, absolute value of velocity, or my speed function. There's my 2 answers. So second, trace, intersect, enter, enter, enter. Gave me that one, so 1.4 is one of them. Second, trace, intersect, enter, enter. And now I have to guess near the other one or else. And it's 0.77. That's 1 point. That would be the second point. That was a 2-point question. So you had to imply the absolute value here. Alternatively, I think if you would have wrote that and solved each of those, that would be fine as well. If you didn't do the absolute value, but you considered forward and backwards velocity, that would have been okay as also. Right? Or sure, it doesn't say on my grading criteria, but I'm positive they would have taken that because it's an equivalent form. Part C says, find the position of the particle at time t equals 4. Is the particle moving toward the origin or away from the origin at time t equals 4? Justify your answer. This is 4 points because there's a lot of stuff to do here. So, the first thing I did was I wrote a position function. Now, there was a piece in the problem where it tells me the initial position of the particle is 7. So I'm going to put a 7 out front. And then I have the integral from 0 to 4 v of t dt. When I do that in my calculator, I get something like this. One point was to remember the plus 7 there. 1 point would be for this. 1 point for that. Now, to decide whether this thing is now moving towards or away, we need to know if we're going backwards or forwards, correct? Because if we're going backwards, we're moving away from the origin. If we're going, moving towards the origin. But if we're going forwards velocity, we're moving away from the origin, right? What's going to tell me that? If I'm moving forwards or backwards at time 4. The velocity. So I'm going to now check v of 4. So on my calculator, how am I doing that? I have my velocity function in y1, so I'm just doing y1 of 4. Yuck. Give me a decimal. Well, I guess it doesn't really matter. All I care about is that that's a positive number, right? So what's my conclusion? And if you wanted to, you probably would include, like, because the particle is right of the origin and moving to the right. But that would have been your last point there. Would have been considering the velocity to make that decision. This last question is 2 points. So it says, during that interval from 0 to 4, does the particle return to its initial position? Give reason for your answer. So let's think about what this is saying. What was our initial position? 7. So I know x of 4 is over here, correct? So I know that if I do anything forward, and then have to come back, it's going to have to go back to that original position, correct? So I want to check to see if we're moving forward really at any time. So maybe I just check for, the position at 1 second or something. Like it doesn't really matter there. You need to pick one though. If I do that, that's 7 plus the integral from 0 to 1 v of t dt. When I do that, I get 9.40 in my calculator. So what am I going to say now? So I'm going to say my goal here is going to be to use the intermediate value theorem, right? So I have a value that's bigger than 7. I have a value that's less than 7. In between there somewhere, it passed by 7 again. In order to use the intermediate value theorem, what do I have to have? Continuity, right? So since the derivative of f is equal to the velocity, x of t is differentiable, which implies x of t is continuous. And then I can say since x of 4 is less than 7 is less than x of 1, there exists some c on the interval from 1 to 4 such that x of c is equal to 7. And I'll say maybe by the IVT. And again, you're welcome to use those 3-letter abbreviations. You don't have to say intermediate value theorem. You can write IVT, MVT, EVT, FTC, fundamental theorem of calculus. Like you can abbreviate those things and that's okay. Those super common 3-letter abbreviations are enough. So you'd get 1 point for this, and then like 1 point for using the IVT. So coming up with the sandwich between the two positions, that would be enough. Remember, there are 9 total points for every free response question. This is where I'll stop here. So I guess we're stopping at free response question 2, but because we just have a couple minutes left. But that's okay. How's this? Is this helpful? Like walking through and like, again, if I'm doing something and you're not sure why I'm doing it, or like if you want to ask, could I have done something else, or like, what else could I do? Please stop me and ask. These calculator problems, I think, should be the easier parts, because if you're comfortable using your calculator, like all the calculus pieces are really, really easy. You just got to kind of know what to do, and your calculator handles like all the details. Like it's almost impossible to muck up the algebra. If you're sometimes I goof up the details. The calculator sections are your best friends because you can use that calculator to really do all of the nitty-gritty detail stuff that it's like I make a mess out of this. And the calculator just handle it. I'm going to put in another practice test. I'm going to drop it into the what's it called here? The OneNote. If you guys want to start practicing on another one. I'm going to drop one in. I'll drop the answers into sometime next week also. But I just figured I'd give you a heads up on that. Have a good weekend.
You too.
Enjoy being seniors. Get a little bit of rest. Maybe study a little bit of calculus if you're feeling up to it. Try like an hour this weekend at some point. Not talking about all the time in the world. Again, for a math exam, study lots in little bits.
Yes.
Like every day, just do a little bit, and you're going to feel really, really good. Because it takes your mind time to like process and cement the stuff in there. The earlier you start and just do little chunks so you never get away from it, the better off things are going to go.
I have a question.
Yeah, what's up?
Can I come in during CT? I do